Just a little bit more about me, given that I began my career in local government as an engineer and then moved through defence in project management and then really started my life cycle journey in Lend-Lease. I've seen construction and building construction specifically from a lot of different perspectives, and ultimately today's talk is going to focus on how we all have a role in using life cycle thinking and life cycle assessment in the design and construction of buildings. But I also want to caveat, this is very much still an evolving space. We are getting better and better at doing this more comprehensively with better data, and that also includes me and my knowledge. I'm by no means the expert. There are many experts in this space, and I'm just happy to be part of one of them. So let me kick off with what is life cycle thinking? So it's really an approach to being mindful of how everyday life affects the environment. So it's the acknowledgement of that broader context. This approach evaluates how both consuming products and engaging in activities impacts the environment. And it not only evaluates them at one single step, but it takes a holistic picture of the whole product or the whole system. And the key element there is the holistic thinking. Life cycle thinking and life cycle assessment aren't necessarily two separate things. However, life cycle thinking can really be done at any time, any stage, for anyone, whereas life cycle assessment follows a very standardized methodology and process to somewhat accurately measure the environmental impact across a range of indicators: carbon, water, mineral depletion, land use, and so on. So that's kind of how I distinguish the two. There are some standard definitions out there, but let's jump straight into life cycle assessment. So the basics. This is the formal process from the ISO 1400 standards, 14040 and 14044. The key elements there are you have a goal, a scope, a life cycle inventory, so your data, and then life cycle impact assessment. And you have this iterative interpretation approach that at each step, you're kind of checking back in. Now, this is a really great and simple diagram, but I think it can be made even more simple. And so in English, as I say, it's 3 real steps. What are we doing? What are the processing steps and data to what we're doing? What are the impacts of that? And that iterative step again of, okay, well, what do all these things mean? How do I apply them? How do I make decisions based on that process? It's still a pretty abstract concept, I think. So when we bring it down to a building, there you break down even further. These 4 concepts turn into a bit more of a process. So I guess at this stage, I'll also caveat, you also need to consider the physical and temporal boundary when you start talking buildings. So there's a physical boundary, which is, the site of your building and what comes in and out of that site. But then there's also the temporal boundary. We design buildings for a set lifetime. They, have a service life, a design life. And in LCA, we normally consider that to be 60 years. And I recognize that that's a little bit out of step with the National Construction Code standards, depending on the importance level. And it's also a little bit out of track with each individual item's service life in a building. So it's a little bit arbitrary, but it's also based on some pretty good academic studies that, residential buildings in Australia tend to live for 100 years plus, whereas commercial buildings tend to be refurbished at the 20-year mark. And when you kind of look at the whole building stock and you average it out, it's somewhere between 50 and 60 years, which is kind of where we're designing for anyway. So considering that boundary, physical site and temporal of 60 years, we've got a couple of stages. The product stage, which includes everything from raw material extraction, processing, transportation between the processing of products. So where a raw material might go to maybe 3 or 4 fabricators or manufacturers before it would go to as a complete product to site, which then pushes us into the construction phase, which includes the transport of a product to site, the construction, installation, energy, water, waste of those products, including things like excavation works. Then we've built our building, we're in the operational use phase, which I'm sure we're all pretty familiar with, which includes not just energy and water use, but the repair, replacement, refurbishment, and maintenance of the products within the building and the building itself. And then after our 60-year life cycle, we're at the end of life. So, you know, it's lived its 60 years, it's kind of at its temporal boundary, and we include the demolition, processing, waste processes, and transport to waste processing sites in the end of life stage. And then finally, there's this stage that kind of sits outside of our temporal and physical boundary as a way of kind of capturing impacts that are around recycled processes, economic value of materials, reuse, and smart end of life processes. So these are things that happen really outside of our building, that would happen anyway without our building, but that our building can directly contribute to or benefit from. So taking this a step further into the standard, we have the lovely EN 15978 boundary stages. So just talking through them individually, you've got A1, pre-building, your product stage, raw material supply, transport, manufacturing, A2 and 3, A4, transport to construction, A5, construction, installation, energy, water, waste. B1 is use, so things like refrigerants, off-gassing, that kind of space. B2, maintenance, B3, repair, B4, replacement, B5, refurbishment, and they all have definitions around the specifics of what they mean, even though they can sometimes kind of all happen at once or all happen in the same way. B6, operational energy use, B7, operational water use. And you'll notice there's waste is kind of missing from that diagram in the use stage, but given the kind of variability of waste processing and you know what happens in a building, it's kind of left out of the LCA space for good and bad. Then we move into end of life stage, C1, which is your demolition, deconstruction, C2, transport, C3, waste processing, C4, disposal, and then that boundary counting module D that happens outside our physical temporal boundary. At this point, I just kind of want to pause and kind of make this a bit graphical. So this is kind of how I visualize it. It's by no means a perfect diagram, but it does raise this element of a gate. There's a lot of talk out there about cradle to gate life cycle assessment or embodied carbon, upfront embodied carbon. The only thing I'll say is essentially most of those terms are talking about A1 to A5. What happens in a product before it gets to your building and it's in its building, its last kind of resting place in the building. Different bodies use different definitions of upfront embodied carbon, cradle to gate. Even in the new Green Star tool, they give you two different pathways. If you do an LCA, you're looking at a pathway of A1 to A5 to your upfront embodied carbon. If you use a simplified pathway, it's A1 to A3, but it's under the upfront embodied carbon credit. So be mindful of those terms when you're in this space. They can get confusing and you can think you're all talking about the same thing, but sometimes not so much. So to complete an LCA, to actually do this process, you need data. There's a lot of great sources of data and different analysis, the depth of the analysis you're doing will determine what kind of data you want to use. But essentially, the way I like to think about it is an LCA for a building is kind of a little bit Inception LCA, kind of like the movie, where you're doing an LCA on an individual product and then you're kind of just adding all those LCAs together for your whole building and extending them out. And if you struggle with that kind of abstract concept, which I mean, I have many times, I like to think about it in terms of orange and orange juice. The LCA on an orange would be like the LCA on a building product, but to do the LCA on orange juice, you need to actually include the LCA on the orange. So, you know, the orange is your building product, concrete, facade, that kind of stuff. Your orange juice is your building. That may or may not help you, but, you know, take what you will. And now in terms of data and where it comes from and this base level, you know, orange level LCA, there's a lot of different LCA methodologies. There's the process-based LCA and there's the economic input-output LCA, and then there's the hybrid of the two. They're sort of the three main types. primarily what you're talking about in buildings is process LCA. We're building the LCA up from the bottom. We're taking the actual supplier data or processes and building them up together. Economic input output kind of goes from the top down. It uses the economic data to analyze and determine material impacts. But because it's based on economic value, it sometimes is not necessarily always applicable. Both types of LCA methodologies have their uses, and most LCAs are actually a combination of the two. But in the context of buildings, the best and most comprehensive data you're likely to get is based on process LCAs. So that's things like an environmental product declaration, real-time monitoring from your contractor, contractor data specifically, those kind of things, whereas your economic output would be your statistical data based on national averages. But I'm sure that you guys have a lot of questions about that. There's kind of no right or wrong. It's just about the depth of the analysis and how you explain your boundaries and your error margins. So let's jump into some general benchmark data. This is a standard benchmark building. It is based on the Barangaroo Towers buildings. It's not necessarily those buildings, but it's based on buildings just like those. So you can see when you break down an LCA and you complete one, your impacts are kind of from operational energy and then followed by your products, your A1 to A3 modules, and then actually your B1 to B5 modules. So that's your use, repair, replacements, refurbishments, maintenance. And then you've got spattered all over the place, transport, construction, operational water, demolition impacts. This diagram doesn't include module B because we're talking about the boundary of our building for the time being. So there you go, operational energy kind of comes first, the use and your product stages. So when you break down your product stage, you get some pretty common trends. So you can see the split here for impacts. Concrete and reinforcement take up 50% of the impacts for the A1 to 3. So basically you're looking at about 12% of your total building impact over its 60-year life. That's pretty big. So there's a lot of things we can do in that space to kind of reduce that or make use of it. Similarly, facade, a facade has a lot of elements in it, glass, aluminium, a lot of energy or carbon intensive elements. So they kind of come up next. And then you're seeing things like flooring. There's a lot of floor space in buildings. Even though it in itself is not necessarily a very intensive product, it kind of adds up pretty quickly. Similar to some of your other finishes, waterproofing, even your services. There's quite a lot of metal, plastics, and materials that go into running services throughout a building. So that's a standard kind of high-rise building. When we compare that to a timber building, it kind of shifts a little bit, mostly because one, we're not kind of in the high-rise space, we're now in the mid-rise space, but also we've got some cool things happening with timber. One of those being that the material itself is about 40% lower embodied carbon than its concrete and reinforcement equivalent. These are approximate numbers, they're rule of thumb, they're not, perfect, and they'll change depending on each individual building because, we never really build the same building twice. But you can see obviously the operational use phase becomes a little bit more significant because we've now reduced the total impact of that A1 to A3 phase. There's a few things that happen with timber when we move into just looking at that A1 to A3, A4 phase. Because timber has a sequestered carbon element, so a biogenic carbon within it. In other words, it's taking carbon out of the atmosphere and it's storing it in the product itself, and it's quite a bit of that. It has this kind of negative carbon inherent in itself, and for a whole bunch of reasons, some good, some bad, we don't count this within the life cycle of a 60-year building for a whole host of reasons, mostly because the other standards around offsetting, carbon accounting and reporting for national averages, carbon footprinting, basically report it year on year. So, the tree was reported as sequestering carbon in its financial year while it was growing. Similarly, offset standards tend to say that we need to sequester carbon over a 100-year life cycle. And if we can't embed it in a building for 100 years, technically we can't count it. So buildings, we kind of lose that element a little bit, but even without that, it's still a lower embodied impact than, say, a standard concrete product. But there's kind of two ways to look at the product stage. There's one including that negative number with the timber and one excluding it. And you can see the relative impact of elements like reinforcement, glazing and facade and flooring kind of shift quite obviously. And it's something to be mindful of, that life cycle thinking approach of just taking a step back and going, well, you know, can I or can't I include that negative element, and should I or shouldn't I, and how should I report that when it comes to the building? Generally speaking, you know, we'd use the one on the right and say, look, without timber, these are the impacts, because we're not going to assume anything about the end of life that we know for sure. We're going to make some assessments to do our LCA, and we're going to do some sensitivity testing and, you know, some checks and balances, but ultimately we're going to exclude it. So jumping next into our case study. So 25 King Street, I had the pleasure of working on this building both from the Lend-Lease side of things and from Aurecon. So I've kind of experienced it from the developer constructor as well as from the tenant, which is a super interesting kind of approach. So it's a building I've got a lot of passion for. And I actually haven't seen complete, so I will be definitely still making a trip to Queensland eventually. But it's a 9-story commercial building. It's Aurecon Queensland's HQ. It's an all timber construction with some lower concrete levels and supports. You can see there was a whole host of people and awards that it received. So it's by no means a small feat to build a timber building, but definitely a fun one. So the LCA results. So the LCA results are for Green Star certification in this case. So it complies with EN 15978 for building LCA. And the indicators used reflect the standards at the time of this study, which was a few years ago now. The assessment is also comparative. So that means we use a reference case and a design case, where the reference case is a standard practice construction, which would be a concrete structure meeting the minimum energy efficiency requirements and the like. So it's a very standard, you know, we didn't do anything special. We met the minimum building requirements we needed to, but it's the same kind of functional use, size and shape of our design case. And our design case reflects the actual building, what we designed in the end, all of the improvements that we put in, whether we changed reinforcement styles, construction materials, so in this case, timber, whether we made changes to facade, all of those things, it reflects the actual building. So you can see the number of indicators that were reported for this building. You've got everything from global warming potential through to like water scarcity, land transformation. And you can see that the different modules listed on the side there have varying different impacts at different stages. But I'm going to give you another kind of view of just the carbon, the global warming potential results, so you can kind of get an idea of what is happening. This is what the life cycle looks like when you're just comparing the reference and design cases for global warming potential across the building. Obviously, the grey, you can see there's quite a reduction in some phases and then quite an increase in others for a whole host of different reasons. So now I'm going to zero in on embodied carbon, looking at modules A1 to A5, and that includes products, transport to site, and construction. And this is really to illustrate lifecycle thinking at play and how you can use lifecycle thinking and lifecycle assessment together. So you can see that the design case in green, light green, performs much better than the other way around, dark green. Sorry about that. I'm looking at two different screens here. So dark green's design case, it's performing much better than light green. And looking at transport, so the A4 component, you notice that the design case actually increases. And ultimately, this came from the timber structure itself. So the CLT and glulam were transported from Europe, and compared with more standard products, construction, concrete and steel, they were focused on more local transport routes, whereas the timber was European, had quite a significant transport route to capture. And I'll point out here that these results are not just the timber results, they're everything in the building. So this is the transport for all of the building materials. So the increase seems a little odd, but we're talking about a pretty large volume of timber and procured over quite a significant transport distance. So you're looking at the transport from Europe over train, shipping, and then road transport to site. It can still have a pretty material impact despite being a pretty kind of short and sharp piece of the construction process. So if we look at this graph alone, we would say, hey, timber's the bomb. It's the ideal product to use. We maybe want to just optimize our transport route. But when we look at other indicators, and on the right-hand side, you'll see land transformation and soil carbon, we can see that the impacts from timber are quite significant, specifically in the production. So that's the, cutting, forestation process and then processing into a glulam or CLT product is pretty significant. If you looked at just these indicators alone, these two side by side, you'd go, well, I don't know about you, but land use is a pretty important thing. Ripping down forests, is this a good thing? Maybe timber is not an ideal product. But if we step outside the LCA process, we know that the timber used for this particular building was Forest Stewardship Council certified. It came from a sustainably managed forest and there was a chain of custody to site. So it was sustainably managed in its process of growing and forestation. This information alongside these results forces us to kind of question, take that life cycle thinking approach and say, are these results valid? Is the FSC certification sufficient in the broader context of having, timber in place for this building? So it's kind of clear here that that life cycle thinking gives us that step back to go, what's the bigger impact? If we're going to use timber, we obviously need to ask a question beyond the LCA that says, okay, we've used timber. Where did that timber come from and what impact did it have in its production and its removal from a tree? And are we okay with that answer? So in this case, we could easily justify these results and say, well, we would absolutely support FSC certified products. And we know that this land transformation indicator is probably overestimated because, so many more trees were replanted and are now sequestering carbon, and that land is being reused in a very sustainably managed way. Is this impact real? Potentially not. So that's not the only impact across the building for embodied carbon or the only embodied carbon initiative that we had in place for 25 King Street. This graph kind of labels out the other significant replacement or initiatives we had in place. So the majority of the reduction, 39%, comes from just using CLT over a standard concrete building. Another 28% comes from using a better concrete product. So that is a high SCM replacement product. It's also about using products with EPDs, not a standardized product, potentially a greener product that specifically goes another distance again to reduce its embodied carbon impacts. There are a whole number of concrete mixes used on this project that in liaison with the concrete supplier were targeted to reduce their embodied carbon impact. So that's where that 28% comes from. 16% for reinforcing, that includes recycled products and reuse products. So again, it was another engagement with the supplier to say, hey, we're not just going to use a standard off-the-shelf product. We want you to provide us with a low embodied carbon product. And in some cases, we even requested the offsetting if that product was over a certain impact to make sure that we could reduce the impact of reinforcing on this project. Similarly, we did the same thing with post-tensioning. That was more a design initiative there of optimizing that structure and process. And then the last one, ceilings, it's 1%, but essentially 25 King Street doesn't have any permanent ceilings installed. So you can see all the exposed surfaces, but just the removal of that one single product still had a quite significant effect on that, quarter of an impact of the whole life cycle of the building. It's 1% out of that 25. It's pretty big for a product we kind of wouldn't look twice at when we think of the big hitters in building. So I purposely focused on embodied carbon and excluded kind of the complexities of the end of life discussion, because I'm sure there'll be plenty of questions about that. But essentially, you know, I'm trying to illustrate here about how life cycle thinking can really aid you in getting to that next stage in design. It's about kind of using the LCA results and making sure that we understand where the data is coming from, which parts of the LCA we're actually talking about, A1, A2, A3, you know, A1 to 5. When someone says embodied carbon, are we all on the same page? And then also kind of giving power to, I guess, you know, the people who aren't directly involved in the procurement, supply and design phase of being able to ask questions. So our development managers to be able to go, okay, what did you do? What were your initiatives? You know, show me that evidence and take that life cycle thinking approach. Because I guess, you know, this next time is kind of just a holder of saying our life cycle thinking decisions accumulate. So every time we take a step back and go, where does this fit in the broader life cycle of the building? We'll be able to kind of add another initiative to our sustainability agenda. So I'm a big fan of life cycle thinking to anything and everything, but life cycle assessment is really the place where you let your sustainability experts dive into the detail, give you the data, and then allow you to step back and have that conversation about splitting the data a few different ways and looking at it from a few different perspectives and asking, you know, what initiative have we made or can we improve on this? So just to kind of round out the discussion, some benefits around timber. There are a lot of them, but anyone who works in our 25 King Street office is a pretty big fan. Natural element timber give a sense of well-being and higher productivity to staff. So everybody loves the fact that they can see all the services running through the building, you know, and they're not painted, they're nothing special, they're just your, you know, stock standard services arranged kind of neatly because they're visible. But it actually gives people a sense of kind of awe that they're in kind of a working and functional building that people really love. It is completely renewable. So even though we can't count that sequestered carbon element, we know that at the end of life, timber is a really valuable product. Nobody's just going to stuff it in landfill and say, call it a day. It can be used for a whole host of end of life purposes, for everything from, you know, being rebuilt into another building, undergoing, you know, the same stress tests you would for beams and steel and the like, right down to, you know, being reused as offcuts for furniture making, for formwork, for all of those elements, as well as, you know, as a waste product, mulching and, you know, even waste to energy processes. So it's quite a versatile product that has a lot of end of life possibilities, and they don't always necessarily show up in our boundaried life cycle assessment with our physical site boundary. They really force you to say, okay, I have to step back and go beyond my building. How am I going to make this the best possible solution ever? Timber is a faster product to build with. The CLT and glulam is pretty much like a Lego box. It's very fun to watch happen on site. It's a little weird to kind of see it go together so quickly, and see how like really kind of safe and simple it is. There's also a lot less staff on site, so it's a much smaller team operating a much faster and kind of lower risk environment. So timber is also lighter than steel and concrete. So where weight is an issue, it's a good option. It's also something to be mindful of when designing with timber, is that, you know, it doesn't have the same spans or openness, cantilever properties as steel and concrete. So it has certain requirements. You know, you're not going to be able to put a giant safe in the middle of a slab of timber. You know, its deflection properties are slightly different. It's a bit more living in the sense that it ebbs and flows, swells and shrinks with weather and the like. So there is a little bit of effort involved in that design phase, but that design phase allows you to kind of put it together like Lego on site. So where you gain more time in the planning phase and you you lose a little time in the planning phase, and you gain more time in the construction phase. But as we all know, that planning phase, more successful projects spend more time in that planning phase getting things right anyway. So that prefabrication notion of timber is a great option. And of course, because, you know, everybody likes the little sucker punch to concrete, is that 8% of global CO2 emissions are produced by cement themselves. That's not to say, though, that there are some really great concrete products out there, and the concrete industry is really pushing to do some really interesting things. And I think we'll see a lot of competition of really cool concrete products in collaboration with timber. And I think we'll really see the future of hybrid buildings, where you've got, you know, concrete-based structures to provide base structural robustness and stability, and then lighter timber structures or hybrid structures using post-tensioning concrete and steel. And it's really interesting what's happening in that hybrid structure space. Even high-rise buildings that are, you know, the two low-rise, mid-rise concrete, and then the high-rise portion timber. It's really exciting what we can do, and we're able to capture all of those benefits in an LCA, and life cycle thinking will get us there. So I'll just end on some of the fabulous awards that 25 King Street has won. I think it's a testament to show you that timber is really kind of well received right now, and a building like 25 King Street isn't actually that showy. When you think about it, it's a pretty stock standard commercial building with some cool features, and that focus on the engineering, the structure, have really allowed it to show up as a clear winner. So that's where I'll kind of leave it for questions. Thanks.
Thanks for that. That was fantastic. Let me just pull up the screen here, 2 secs. Right, so I would encourage anyone, if they've got some questions, to start putting them into the question section, because we do have a little bit of time to answer it, and the question and answer section is always good with some good interaction. So thanks once again, Melissa. You've taken a very complex topic and certainly presented it in a nice, succinct way. So the end of life, as you mentioned, was going to generate a number of questions, and we have had a sort of few questions come around about that, about, you know, how does recycling affect the LCA and those type of things. Yeah, do you want to talk a little bit more about that? I mean, I think the end of life one is really interesting, as we're seeing more mass timber come out, because you mentioned before, currently when life cycle practitioners are looking at, they have this sort of problem that they don't know what's going to happen with that timber in 60 years' time. So what assumption do you make? But I think the thinking is going around at the moment, particularly in Europe and the US and New Zealand, that clearly if you're putting something like CLT into a building, which has a high level of value at the moment, because of the beauty of the fact with CLT, you can deconstruct it. You can just unscrew it all. It's not like you have to demolish the building. It is all about design for deconstruction. That clearly in 60 years' time, that CLT panel is probably going to have a lot more value than it does in present day terms. I wonder, what's your thoughts there about how we need to be re-looking at some of these products at the moment when we're doing our LCA, because of the fact in, you know, at the end of life, they will have a certain, you know, real value, like you mentioned.
Yeah, absolutely. I think there's a couple of things. The first one I'll say is that, you know, buildings that stand the test of time, that get refurbished and loved and never kind of demolished, are the buildings that have a natural kind of beauty to them. They're the buildings that people walk into and kind of feel at home in. And that often isn't flashy design. That's often really functional and smart design. And timber really has that element. So I don't think we'll actually even see a lot of timber buildings being deconstructed, because I think they'll actually have a sense of warmth about them that will outlive kind of their original purpose. And they'll be able to be repurposed very quickly because of that factor. So when it comes to doing the LCA assessment, the end of life processes, we do a couple of things generally. We make some assumptions based on statistical data that's out there in the region that we're doing the LCA. So in Australia, we look at what's the current recycling process now that's in place. And right now there isn't really one for CLT and glue lamp. So we would look at other regions like Europe and say, well, what do they do? And ultimately, we don't generally see them knocking down timber buildings. So we would say, and when they do, they have a lot of processes for waste to energy. Timber doesn't generally land in landfill. So what we would normally do is we'd pick which one we would think is most appropriate for our building, because it will depend on, what type and typology and location, those things. And then we would kind of sensitivity test that and say, well, okay, well, even if we did assume the whole building went to landfill, how sensitive is the overall LCA to that assumption? And we do some tests and say, well, what would happen if we put it to waste energy, and what would happen if we reused it? But the thing to remember in all of those elements is that we're only talking about our physical boundary of the project. And when you think about really making sustainable change and doing sustainable initiatives, that's not the boundary you want to be thinking about. We don't build sustainable buildings for the one building. We build sustainable buildings for the planet. So I think you have to take that real life cycle thinking approach and say, what are we doing this for beyond this building? And how can we provide commentary and interpretation of those LCA results to show that, we're going to put a green lease in place, or we're going to, put a clause in our sale contract that says, we want you to dispose of this building really thoughtfully. It's been designed for disassembly. Here is the manual that comes with it on how you would pull it apart. Here are the people that supplied you the product so that you can do that. It's about taking those steps, and those steps allow us to kind of look at the results and say, well, actually, just like the FSC land use indicator, we could say that indicator is not actually real. That data is showing us that there's a area of opportunity or a risk that we can actually hone into, but right now that's not going to actually appear in your LCA. It's going to sit outside of that process because there isn't a good process. And that also applies to all structural products and in a building. It applies to concrete and steel. We often say, oh, we think this much concrete gets turned into rubble and reused, but that's just an estimation. We don't know if that's actually happening. So we need to do the same thing for those processes too.
Yep, thanks. And a question just to context a little bit of what you said before about your comparison. Someone's just asked about the reference case you used.
Yep.
Just how that was actually established. Can you just clarify that?
Yeah, so our in this case, the designers actually designed a standard concrete steel construction. So they looked at the same footprint and they did sort of the same concept design process where they said, this is what the building would look like if we built it out of concrete and steel. So it was then put in a cost plan, and a bill of quantities was generated to be able to provide the reference case. That's not always necessarily the case. Sometimes we have to make assumptions based on GFA of what we know would go in a building. So we've got an approximate GFA. So we'd assume, okay, it's this much concrete per GFA on a standard construction. And there are some pretty great academic studies out there to grab that data from. So as long as you make that assumption consistently across your reference and design case around how you're designing, it's a comparative assessment, and the process kind of allows you to make those judgment calls.
Yep. So another interesting point you made, which I knew was going to generate a bit of interest, was the fact that, in terms of the tools that look at this, we don't recognise the biogenic carbon. I mean, you mentioned about, building could be 60 years, but, the period's 100 years. Yet we've chatted before about like CLT is going to last more than 100 years. We know that it's going to go into another building. But Jack here also asked, given the global goal, at least referring to the Paris Agreement, is to reduce carbon emissions by 2050, how do we communicate to clients that timber should have a significantly better carbon emissions in the short term? It probably brings up that concept about the substitution effect, which is looked at in a lot of countries. Okay, even if you're not measuring it, if you transfer a lot of your stock from something like concrete to carbon, that is having an effect because you're not using a sort of as much concrete, which is a very high CO2 emitting material. I know in Germany, they're starting to look at the moment, work that up, what that substitution effect, actually might mean on a regional scale. Well, what's your thoughts there on the substitution effect and, how that should be perhaps included if we're not actually, capturing the biogenic carbon in our tools?
I think the thing that we forget here is that even if you just did a like for like comparison, a timber building is still 40%, lower embodied carbon just from the substitution from concrete to timber, excluding that sequestered carbon portion. So you're still getting a huge reduction. So you need to do some pretty significant things in concrete to meet that same reduction. And that's a pretty big challenge for the concrete suppliers out there and the steel suppliers to be able to get there. But it also promotes a discussion of we're not going to be able to just build timber buildings without some really smart supply chain systems in place. So it's not a like one is better than the other. It's about looking for what is the best material for the design I have right now. If you're talking about a mid-rise building that isn't, you know, an importance level 4 that is going to be in any of the Australian major cities, you're probably looking at a timber product being a more useful, efficient process from design to construction. And I think we need to kind of get out of the headspace of this is a, you know, it's not a one trick pony here. Like timber has a lot of benefits that we need to kind of step back and go, we're building timber buildings because we get to spend a little bit more time in design. We get to place an order early. We get to have a small construction team on site. There's a lot of benefits to a developer there that they'd be looking for, returns on investment that they might get quicker by choosing a timber product, even when, you know, the cost of timber is slightly higher than its concrete equivalent right now. And I definitely think we've got a lot of work to do in the national greenhouse accounting space in terms of looking at substitution effects. And the more EPDs we get in place, the more kind of discussions like this we have, we'll be able to put pressure to kind of have that data.
Yep. Gabriella was asking just about, I guess, during the operational phase about in different climate zones. So in warmer and drier climates that require higher thermal mass, a timber building may need more AC in the summer or require the installation of concrete radiators or PCM ceilings, for example. She's asking, is timber still a good choice in this case?
I mean, I guess it would depend. There's not a yes or no answer always. I think it could very much well be done. It also depends on, you know, what is your energy strategy? Are we looking at passive, you know, heating and cooling methodologies? Are we, you know, is the set point in the, you know, air conditioning the right one? We know that, you know, our energy kind of standards in commercial buildings are operating at a much higher place than they probably need to be. You know, I don't think I know a woman who isn't cold in a commercial building. So there's a lot to be done in that space holistically. And I think we've got to look at timber is it the right for that particular bespoke solution? I don't see any reason why you couldn't put a timber building in those places at all.
Mm-hmm. There's been a couple of questions just about the different types of mass timber products, particularly CLT and some being imported. I mean, have you found just in your experience any difference between the different products, locally produced or imported, particularly around sort of, you know, sort of manufacturing glues and things like that?
Yeah, so there is a little bit of a difference, predominantly because the European market is much more mature than, I guess, the Australasian market. And that's reflected in the resins and glues that are used. The process is very similar, but there's a few things in Europe that tends to happen that we don't really do because of our climate in you know, the Australasian market. The waste to energy process is the big one. In a lot of the European manufacturing of CLT, the offcuts and the, you know, sawdust is all reused in their own waste to energy process, so that the individual process is a little bit more efficient. Whereas when you take the Australasian context, it tends not to have the same level of efficiency, but it is a much smaller market and it's a much younger market. So it's kind of not at that place yet. It also doesn't have the same stock requirements. There's a lot of timber buildings going up in Europe. They have a lot more mid-rise and low-rise. They have a different climate that allows them to put more timber buildings in. So it's a bit of a catch-22. It's kind of, you know, comparing apples with oranges, and it's kind of a little bit unfair. I would say though that I am seeing more and more evidence to show that all CLT suppliers are looking at the choice of resins and glues they're using and making statements on formaldehyde and VOCs, which is really great to see. And I don't think I know of one that isn't reporting on that. So the data is there for you to make a decision on, and they all vary slightly. And I guess the other element of that is, you know, their process is, you know, their competitive advantage. So it's about choosing the one that's going to work for you. And that might be based on not just, you know, its VOC or resin process, it's also, and it's, you know, carbon impact, but its availability and how quickly it can get to site and how you want to design. So there's a lot of elements to consider with that. There isn't one amazing supplier and everyone else kind of trailing at this stage.
No. But with the comment around design for disassembly, that generated a couple of questions about, you know, what happens with composite type products like timber concrete floors or sort of fitting plasterboard to timber walls, which are good questions. Keen to get your thoughts here, but I guess in some respects it's a little bit of an example of the benefits of life cycle thinking, because we're so used to constructing things in a past way, that if we're thinking now design for disassembly is important, I guess it just means as we go forward we come up with more creative ways of designing up front to disassemble things at the end. Did you have any thoughts on that?
Yeah, absolutely. So the design of timber buildings I've seen is that you end up excluding a lot of products, so you're not putting in extra walls and partitions and coverings and surfaces that you would over, say, a concrete structure. And a lot of that is because the timber structure provides you a kind of great, atmosphere that you kind of don't want to cover up or enhance in any way. But composite products are always an issue in the life cycle process because of their difficulty for disassembly. And I guess the more natural products, my thinking is very broad in that we really need to focus on the more natural products we can in buildings. The number one step in when people ask me of, what is my first thing I need to do to reduce my embodied carbon or my impact in my LCA, my answer is always dematerialize. Take things out that you don't actually need, and be smart about the things you do need. Are you putting an access floor and then a carpet over that access floor, or is there a product that provides you the one solution? And are you putting in an access floor to allow you to move things around to make things flexible, or are you just laying a floor straight on timber because you decided that's where the floor level was? Those things are the kind of questions, but the key is remove the material. If you don't need it there, it has to be there for a reason, and just to look pretty is kind of not good enough anymore.
Mm-hmm. I'm interested to also get your thoughts. Over the past 10 years, as we've started to look at the sustainability of buildings, the focus was initially the operational phase, which is fair enough. But there's always been the comment from LCA practitioners, you shouldn't just cherry pick and look at one bit, you should look at the full life cycle. Now we seem to have moved beyond operational energy, which is great. So now there's an interest in sort of embodied upfront carbon and end of life because of circular economy interests. Yeah, what's your thoughts again there about that? I mean, again, it's almost like cherry picking back at sort of different phases of the life cycle. I mean, that has its value, but I'm sure as an LCA practitioner, you understand the value of looking at the full life cycle, because you might have a good sort of outcome at one part of that cherry pick phase, but that may not translate across the full life cycle. Yeah, keen to get your thoughts there, particularly the interest at the moment in embodied carbon.
Yeah, I think it's great to see the market shift to a focus on materials, because I think there's a lot of things that can be done in the materials space to really push us along this embodied, like, lower carbon economy journey. But I will, life cycle assessment, those modules aren't there as a trade-off. You're not going to improve one so you can, not improve the other. The whole purpose of that reference case, design case, is a comparative study. You're trying to get every module to be lower in your design case. You're not aiming to make your A1 to 3 go up and your A5 go down, and it's not a trade-off. That's why it's a whole process, and it kind of should be reported as such. And the reason we break them down is to give us the ability to deep dive and target areas, and we should recognize that that's kind of all it's there for, and we need to step back out. And it's that iterative process in that first initial slide of the life cycle methodology. What does it all mean? Whenever we do a step in LCA, we kind of need to get back to that and go, okay, I looked at this, I saw some trends, I looked at each indicator. Life cycle assessment gives us way beyond carbon. We're talking about water scarcity and mineral depletion and soil carbon, land use change. Like, there's a lot of elements there to consider. So we should really be, okay, we've dived down into material embodied carbon impact of something. Great. Now we need to step out and say, what does that all mean? And keep going through that process. If we're doing that, we're allowed to kind of dive in deep and come back out. If we're not doing that, I would question, there's probably a loss of value in cherry picking. It is really kind of, it's targeting the industry, but it's maybe not, it can be a little bit perverse, I guess I would say.
Mm-hmm. And how are you seeing the sort of proliferation of different tools now to help, try and for people to understand this? Is that useful to have like embodied carbon focused tools, or do you think we should still be, looking at a full life cycle assessment and having sort of easier ways of doing that?
I think you should always have personally, I think it's always a life cycle assessment. I think that is the way to go. I think a life cycle assessment should build. It is the process described in all the standards is meant to be iterative. You're meant to do it more than once. Every kind of change, you're meant to kind of step back and assess. That's the kind of process. And I would argue that, you can build up your life cycle. When you're at concept phase, of course, you're not going to know exactly which door you're going to include in your building. That's okay. But when you're at detailed design development going into IFC, you should really have a good idea of where that is. And you should build your LCA accordingly. So yeah, at first in your concept stage, you should be really looking at your key elements, trying to make some big decisions. But every step you make where you've made a new set of decisions, you should be including more data in that LCA process. And I would argue that, if you've got a sustainability person on board, if you're following a Green Star process, it's really easy to have an LCA practitioner in amongst those professionals. Your sustainability professional probably already has someone in their team or is one themselves and can give you advice on that. And I think we need to be aware that just like the concept design process, the first concept we put on the page is not the one we end up with at construction or when we open the door to a building. And similarly, the same goes with LCA. It's an iterative process and no number is ever kind of set in stone. We've also got to remember that we don't have all of the data for every little element that goes in the building, and some of it's not material. So we need to be conscious of the fact that, I'm not going to be able to account for every little screw with every little piece of detail. And that's okay because it's probably only, 0.0001% of my total impact. And that's all right. And similarly, throughout the process, we need to allow ourselves that flexibility. We made an estimate, we got our estimate wrong. We were a bit too high, we were a bit too low, but it's an iterative process. I guess I can't say that enough. It is an iterative process. You need to do it more than once. And if you've just done it once, you probably haven't taken the full advantage of what it can do.
Yeah, absolutely. And how do you find that now with new projects that come up? As the client and the sort of and the professional group that comes together, they see the sustainability understanding as an important part, the life cycle thinking? You're finding that more and more often now?
Yeah, absolutely. And we're finding there's a lot more discussion around like roadmaps, strategies, pathways that clients are asking for. So a lot of our developer and constructor clients are asking for things they can do again and again and again on projects. So one of the life cycle thinking things, I like to quote that we were able to do at Lendlease while I was there was really hone in on their construction process. That's something that, Lendlease Construction did over and over and over again. So why not take advantage of making that the most efficient it can possibly be? And they've since gone down the pathway of making that a carbon neutral process. Similarly, at Oricon, we do the same thing for our clients, giving them an embodied carbon roadmap when they sign up for an LCA with us. It's part of the process of doing an LCA. We review things at every stage so we can get in there and provide them opportunities to make better choices. And there's a lot of acceptance and discussion around that. People want to know more and they want to understand the terminology. And I think, more of it is being asked for and more of it is being provided, and it's great to see. And I guess the only caveat I would say to that is, it's a very complex topic. It's very difficult to kind of sift through. I probably talked about a lot of really complex things that I didn't explain in full. And I think we need to recognize that not everybody needs to do the LCA or be the LCA expert. We should leave that to the LCA practitioners and let them share their knowledge with us and then be able to, communicate that trend data, similarly like we would with any other profession.
Well, it's been fantastic, Melissa. We're just about out of time, but you've taken a very complex topic and explained it extremely well. So we thank you for that. I'm sure the audience has really appreciated it as much as I have. So thank you once again. Just a reminder to everyone that the webinars are recorded, so you can just go to the Wood Solutions website and download it. This one will be uploaded over the next couple of days. So if you're interested in passing the details on to your colleagues, please do so, because there's some great information there. Just also a reminder that Wood Solutions puts out a wide range of different resources. Some of the in-focus tools that you can download there from the website are also certainly worth viewing if you haven't done already. Now, we normally hold our fortnightly webinars, and I'll get to it shortly, obviously every 2 weeks, but actually next week on Thursday the 10th, we've got a special webinar that the Midrise team's organising. So actually a good sort of supplementary and complementary webinar on what we've listened to today. This will be on opportunities for cutting embodied carbon and the role of timber structures. So recently, the Clean Energy Finance Corporation, in conjunction with the Green Building Council of Australia, released a fantastic industry report, which was developed by Edge Environment. And Jonas Bengstrom will be along to talk about that, and Christina also from the Finance Corporation. So please, if you've got an interest in this topic, log into that one. I'm sure you'll find it fascinating with this embodied energy, embodied carbon component. That's next Thursday, the 10th at 11. But in 2 weeks' time, we'll have the next of our fortnightly webinars. And for this one, we've got a case study on the Adelaide Oval Hotel. So a great timber project. And the presenters are two of the people who are sort of key parts of the development team. So please tune into that one on the 15th of December. So thank you all once again for your participation and support. We look forward to seeing you again in a couple of weeks' time. Have a great day.